we can do nodal analysis with the AC circuit, right? So you already know the concept of nodal analysis with the DC circuit, right? But now we'll do nodal analysis with the AC circuit. All the things are same. You don't need to change anything. Just draw the diagram. I am taking the numerical. Yes. This is, they have given 1.5 cos 100t. This one they have given as 2 sin 100t. This one is 10 ohm. This one is 200 microfarad, and this one is 0.1 Henry. Okay, so now tell me, how many nodes do we have in this case? And this will have two nodes, V1 of t and V2 of t. Okay, they have mentioned in the question only V1 of t is and V2 of t. So now apply KCL at node 1, that is this one, this one, this one, right? So tell me, what would be the equation? First of all, you need to convert the standard equation into the polar form. That is 2 cos 100t minus 90. So polar form, it's not the polar form now. Not 2 comma 2 angle. No, you can directly write down now. If it's 200t minus 90, and so its polar form is 2 angle minus 90. Okay. Now tell me for this one, what is the polar form? Correct. So it would be how much? Tell me the equation. The node 1 V1 equation. Yeah, angle minus 90. No. See the magnitude, this one is the current, right? And you put minus. That's why. Okay. Now the next one. V1 divided by 10. Then it's 200 microfarad, right? So for that we need to calculate XC, right? Or that would be how much? XC is equal to minus J over omega C. Minus J will be as it is. Omega is how much? 100. Capacitor is how much? 200 into 10 raised to power minus 6. So now solve it and then tell me the value for XC. 5. Tell me the value for XC. No, I think you have done some calculation wrong. It is minus J5. XC is minus J5. It's sorry, it's 2000. It's 2000, not 200. it's 2000. Okay, now you got XCS minus J5. Got it? Now next thing, tell me, it would be how much? Hmm. Yeah, V1 minus V2 over minus J5, right? Correct? Is equal to 0. Okay, I'll tell you how to solve it. First, tell me node 2 equation. Hmm. 10. XL is V2 over J10, then minus 1.5 angle 0, then is equal to 0. Correct? Now see how can we solve these equation. We can take V1 term one side and V2 terms one side and the constant term on the another side. So I am taking one of the example. It would be V1 by 10 plus V1 by minus J5, then minus V2 by minus J5 is equal to 2 angle minus 90. Can we write it like this? V1 we can take it common, 1 by 10 minus 1 over J5, then minus V2 and minus minus will become plus, so 1 over J5 is equal to 2 angle minus 90, right? So now you can solve it like 1 by 10 is how much? 0.1 minus 1 by 5 is how much? 0.2. So minus J is 0.2, right? V1 plus J5 is 0.2. So J 0.2. Then 2 angle minus 90. It's in polar form, right? All are in J form. So can we convert it into rectangular form? V2 also. Okay, now convert this polar form into the rectangular form. Hmm. No, 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 no. I'm saying this one is in the polar form. 2 angle minus 90. Convert it into the rectangular form. What it would be? Yeah, yeah. You need to press REC on the calculator. So we can write down minus J2. Yes or no? Similarly, can we get the second node equation? How much you got it? Second node, wait, it's hang. Similarly, we'll get the second node equation. Now, can you solve it further? Two variables and two equations. Yes or no? Wait it. Okay, now solve this node V2. Do it. What you have done? It is C. It is 0 now, so you can simply write down 1.5 plus J0. You don't need to convert it. Okay. Now solve this one. Take V2 common. Okay. Now solve it this one. And 1 over J5 is how much? It's 1 by J10, 0.1. 1 by J minus 1 over J5, right? 1 over 5 is 0.2. So it would be minus 0.2 over J. Put shift this J into the numerator, and you know now how to shift. So now you will get some particular equation, right? Now I'm writing the final two equation. For the first equation, we are getting 0.1 plus J 0.2 V1 minus J 0.2 V2 is equal to minus J2, then minus J 0.2 V1 plus J 0.1 V2 is equal to 1.5. This is the equation, right? Now in this case, how can we can solve it? We need to calculate the value. We can do it in your calculator also. Okay, but you for that you should know the matrix method or determinant method. Do you know what is determinant method? Okay, I'll tell you. I don't know how your teacher has done. He has done directly or by substituting. But if it is of three variable equation, you can't do it by substituting also, right? See, one of the option is with you is you are having V1. I'll tell you both the option like J 0.1 V2 is equal to 1.5 plus J 0.2 V1, right? So V2 is equal to 1.5 plus J 0.2 V1 divided by J 0.1, right? Now we got the value of V2 and we need to substitute it here. Then we'll get the final equation in form of V1 and then we'll get the value for V1. This is your teacher have done. Okay. Now it's is difficult for the student. Can I tell you my method or you need to do it by this? What did they do? They calculate any one of the value from one of the equation. Okay, you can calculate either V1 value or you can calculate either V2 value. Okay, it's simple now. Then do it. V2 we can substitute it here. So it would be 0.1 plus J 0.2 V1, right? As it is, minus J 0.2 is equal to minus J2, right? Solve it further. Wait, let's solve like this. J would be cancelled. 0.2 divided by 0.1 is how much? Hmm? 2. So multiply 2 with the inner value. 2 into 1.5 is how much? 3. 2 into 0.2 is how much? Hmm? 2 into 0.2 is, yeah, 0.4 V1, then plus J2, right? Now I'm taking V1 term one side. So can we write down 0.1 V1 plus J 0.2 V1 plus J 0.4 V1 is equal to 3 minus J2. It's minus, na? So it's there, it would be plus. Mm. So calculate the value of V1 from here. Zero point 0.1 V1 plus J 0.6 V1 is equal to 3 minus J2. So further, if we'll solve it, 0. V1 we can take it common. 0.1 plus J 0.6 is equal to 3 minus J2, right? Now V1 is how much? That is 3 minus J2 divided by 0.1 plus J 0.6. Yes or no? Then you need to solve it. Yeah, do it in the polar form. Okay. Now tell me. Hmm. Hmm. Top one is how much? 3 minus J2 is how much? Wait. Here it's a bracket. So in this case it is 0.4, it is 0.2 minus J 0.2. So the final is 3 minus J2, 0.1 minus J 0.2. This is the final value. Okay, that was I. Okay, now tell me 3 minus J2 is how much? Convert it into the polar form. Hmm. Okay, and this one rectangular form. Hmm. Now solve it further. Answer should be this. 16.1 angle 29.7. Okay, now this is, you got only V1, right? You need to calculate V2 also. You can substitute the value of V1 in any one of the equation. Then after solving, you will get V2. Got it? Okay. Now, the next topic, the mesh analysis for the AC circuit. Okay. Same procedure, same method. This is the value they have given. Okay. Now same equation, like this is suppose I1 and this is suppose I2. First you need to convert this one into the polar form, right? That is 100 angle 0. Convert this into the Excel form. J omega L. So how much it is? J100. It's 1000 Tina. So 1000 Hmm? Yeah, already it's a resistance now, so we don't need to the same way which we have done. Yeah, 100 I1 minus I2. Now similarly calculate XC. So it would be minus J 200. Now similarly this one J100, right? So now can you get the mesh equation for the first mesh? Hmm. I1 minus I2 is equal to 0. Now tell me the second mesh equation. Hmm. I2 plus J100 I2 is equal. No, you can add, basically you need to solve it. You need to solve I1 and I2. Similar the way which we have done earlier. Yeah, we can add them. Then it would be minus J100 I2. This one, right? And what would be the first equation then? Tell me. Take the I1 common. Hmm. Then calculate the I1 from the first equation. you can calculate it from any of the equation, that depends on you. Hmm. Yeah. Hmm. Yeah. And then we can substitute the value in the first equation, right? Okay. Now the next is superposition, right? Did you know, remember the steps of the superposition in the Thevenin, in the DC circuit? Hmm. See, it is 10 sine 1000t. This is 10 microfarad. This is 0.2 cos of 1000t plus 90 degree, right? So what will happen in the superposition theorem, will take first source at a time and then open circuit another source. Remember, one source at a time. So in that case, voltage source must be short circuit, right? And current source must be open circuit, correct? So first source is voltage source, I short circuited it. Now I'm taking the current source. So in this case, tell me the current source value in the polar form. Hmm. So now how can we solve it further? That is 0.2 angle 90 degree, and they have asked you to calculate current. Now how many meshes are there in this case? Hmm. Yeah. So can we calculate if there is current source, like we turn off the voltage source, and this one is how much? Now we need to calculate j omega L, right? 100 will be here as it is, and for this one we need to calculate j omega c. Calculate the value for xl or j omega L for this case. For the inductor. And similarly for the capacitance. Right. Now all the three impedances are in series or in parallel? Parallel. So can we solve it? That 1 by Z1 plus 1 by Z2 plus 1 by Z3, then we'll get Z equivalent, right? So if we know the total impedance and the total current, can we convert it into the voltage source? And can we get the current in each and every element? So that totally depends on you. If you want to use nodal analysis for calculation of current, you can use nodal. If you want to do mesh analysis for calculation of current, that you can use mesh. But for superposition theorem, I'll suggest you do it by nodal. That would be easy for you. Okay. Okay.